Uh, right, and thank you. I appreciate your presence, everybody. So I'm Mohammad Ashik Falil. So I'll be talking about how to control devices or automate devices in your home, be it a light or whatever it is, using PowerApps. Right, and before I start, I would like to also thank the organizers for their effort in convening such a big event. Thanks the organizers and also the sponsors. Yeah. So this is me. I'm a solution architect working for Tata Consultancy Services, and my I work with Microsoft 365 services and also Azure. I'm also a Microsoft certified trainer, and these are my social handles. My LinkedIn, Twitter. I'm also a blogger. You can take a look at it, and whatever I'm going to talk today, I've already written a blog post on this the specific topic. And I'm also an organizer of an user journey group called as a cloud journey user group, and it has been started a couple of months back. And I run this group along with my friend. I've got a couple of interesting sessions as well scheduled in upcoming months. So that is about me. Without further ado, I will go. I'll now speak about what we are going to see on this 1 hour. Uh,
Hello. I'm sorry to nudge you in between. Can you please share your blog details? I'm quite curious about that. And the conversation
yes, yes.
chat.
So the presentation will be shared with everybody, I believe, but the organizers will be doing it. And you have the blog links there, and also on the references section, I have got link, which will help you specific to this particular session.
Okay, that would be really great if the organization share
Yeah, yeah,
the.
we will be sharing the slides and everything post
Thank
the
you.
event.
Okay, thank you.
Yeah. So this is the agenda. So we'll be looking at what is Raspberry Pi and what is Arduino UNO, because these are the hardware devices which I have used for this session to control the devices from anywhere in the world using the Power App. And also we'll be looking at the prerequisite for you to kickstart, because there are a lot of different components which you might have to configure with your Raspberry Pi and also the Arduino Uno board. And then we will see how to control the devices. I will walk through the different components associated for this particular session. And at the last, we'll have questions, and also I will be showing you a live demo. I'll be showing the lights, whatever I have connected. So it is not an a high-powered device. So it is not. We are not going to control light or fan because of this demo. I
Ashik,
can't really
I
show that.
think um, your another that camera is not shared. I think.
I'll be showing that. Right now,
Yeah.
I share only the presentation, and I'll be showing it once I start the demo.
Okay, fine, fine.
Yeah, yeah. Okay. So let's see what is Raspberry Pi. Most of you would have heard about this. It is a credit card sized computer, and moreover, it is low cost, right? And you everyone can afford it, and when it so in INR it comes close to 5,000 rupees, and you can actually RDP to a Raspberry Pi which is running Raspbian, or it can run the other operating system like Ubuntu, Windows 10 IoT Core. So these are the different operating systems which Raspberry Pi supports, and there are a few other operating systems which I have not mentioned here. And Raspberry Pi has got GPIO pins, which is specifically used with IoT projects. And if you have to control a device, right, you have to leverage the GPIO pins. It is called as general purpose input or output pins. And here for this session, I have used as an output, right? We are going to be sending digital signals to the Raspberry Pi GPI open, which can be used to control a device. It can uh, activate a relay, which is connected to a high powered device. So this is the schematic, whatever you see here. And I have used Raspberry Pi 4, which is much better than the previous versions. It has got a 4 GB RAM, and also you can also have an 8 GB RAM Raspberry Pi 4. And it has got a Wi-Fi adapter. It has got an Ethernet adapter. So the operating system has to be loaded on a micro SD card, which has to be plugged in here. And it has got USB ports. You can also connect to a keyboard, a monitor. It is a small computer, a really a powerful one. So this is the GPI opens, the one you see here. This can be either be treated as an input or output, as I already said, right? So the input, if you use the pin mode as input, you will have to you can the use case is for sensors. So when you have to send signals, temperature, measure the temperature or humidity. In those cases, you'll have to configure the pin mode as input. But here for this session, I've used the pin mode as output so that we can control the device. So with that said, now we'll look at what is Arduino UNO board, and it is actually a microcontroller based board, and it is not it can't run an operating system when you compare it with the Raspberry Pi, right? So it has to be hooked up to your laptop. So it is very cheap, and in INR it comes close to 500. You can order this particular hardware from Flipkart or Amazon.in. So here, if you have already worked with microcontrollers, if you have to talk to microcontroller, you'll have to do a lot of things behind the scenes. So Arduino, it is actually an open source, which has also produced a software, Arduino software, with which you can easily program easily talk with your to talk with the microprocessor, right? And similar to the Raspberry Pi, it has also got the input output pins, and it has 14 pins, right? So it is exactly similar to the Raspberry Pi, and this is also where it is also predominantly used in projects, IoT projects, but not on a commercial basis. But your pet projects, it is more than enough for you to kickstart it, right? And it is not Wi-Fi. It is not Wi-Fi capable. This, at least this UNO board, but there are other boards which is available in the market, which is a bit expensive compared to the UNO board. It has got a Wi-Fi as well. So based on your needs, you can buy the appropriate boards with features. So the UNO board communicates using a USB port. It is powered using an USB, and you all know that USB it generates it produces around 5 volt, which is more than enough to power up this UNO board. And the Arduino software it uses the serial port within an USB to communicate. Right, and these are the pins. It has got 14 pins, and also here it also generates 3.3 volt and 5 volt. So with this, you can easily power up an LED, small devices, just LEDs, right? And if you have to, for example, run a motor, control a motor, a stepper motor, etc., you'll have to then externally connect here. So this socket, you can power up external power supply, right? So with that said, I will go for the Raspberry Pi, whatever the prerequisite you should have before we start it. right, and start working with the IoT project. So I have got a Raspberry Pi 4, and it is Wi-Fi capable. It is connected to my Wi-Fi router here, with which we will be able to talk to the Raspberry Pi from IoT. Right. So here, what we when your Raspberry Pi is connected or it's configured for Wi-Fi, the router, it will assign an IP address, right? So you should know the IP address of the Raspberry Pi so that we can remotely connect to your Raspberry Pi. I will show that how to do it, and also remotely code with your Raspberry Pi using Visual Studio Code. And there are actually plugins which is available. So I have also used breadboards to extend the GPI opens to test it, to test the signals, etc. Right, and I've got a couple of jumper wires and resistors, LEDs, and relay module. This is something which you'll be needing it if you have to control an high-powered device. So, for example, if you've got an AC light or a fan or etc., so you will need this, right? And Raspberry Pi, the version which I've got, it runs a Raspbian operating system, and also I have installed .NET Core 3.1, and it also supports .NET 5. Right, and the Raspberry Pi, I have enabled secure a socket host with which we'll be able to remotely connect. And this is something which we'll have to do it. I will show you how to enable this, and also you would require root permissions. It's a Linux based operating system, Raspbian OS. And next one, so with Visual Studio Code, and as I said, there is a plugin which will help you or facilitate for you to do remote development. And also there are a couple of packages which you might require. One is to get package manager, and this will help you to add packages, which I'll be showing down the line. And also we'd be using a console application, a .NET Core based console application to for this project. I'll be showing this in the upcoming slides on a detail level. So next one. So this is the design. So this is how I'm controlling a device from a Power App. So this is Power Apps, and for this example, I've got two LEDs, which I'll be controlling it from the Power App. I've got two toggle controls. What happens is when I turn on or turn off, it sends a signal. So these are the different components which is required. It sends a signal to the Raspberry Pi, which has a .NET Core console application running on it, which will expect keep looking for signals. Right, whenever there is something you turn on or turn off, it receives that and it turns on or turns off the light. Right, and how it sends the signal is through IoT hub. So we are using an IoT hub, and I have got a device registered in the IoT hub. So when we turn on or turn off, it sends a signal through an Azure function. And you know that Power App has got lot of standard connectors. And if you have to call an API, a custom API, you will have to use a custom connector, right? So this enables you to call any API. So in this case, I have used an Azure function API, which will be sending a message to the IoT hub, which will be received by the .NET Core console application. So here, these are the different components. I said it has a console application running, the .NET Core. So that particular console application has got these two packages. One is system.device.gpio. So this particular package, it helps you to talk with the GPI opens on the Raspberry Pi. So this is a package created by Microsoft, and it is actively maintained. And next one, Azure Microsoft.Azure devices.client. And this is another package which will be requiring it in order to talk with the IoT hub. So whenever there is a message for a particular device registered on IoT hub, it actually we will be able to receive that message on the .NET Core Console application. So next one is here. The next component is the IoT hub. So on this session, I have registered a free tier IoT hub, and it is free. You no need to spend anything. So you can use it for experimental purposes like I have done, and you can register n number of devices on the IoT hub. And moreover, per day, you can send up to 8,000 messages. You will be understanding while I show the IoT hub what is actually a message. And next one is an Azure function. So I have an Azure function which is based on an HTTP trigger with authorization level as function. Right, and it has got a Nugget package which is installed on the Azure function. So I have created an Azure function using Visual Studio, and not the code. It is Visual Studio 2019. Right, so this particular Azure function sends a message to the IoT hub, and IoT hub then will sending that message to the console application. Right, so next we have got a custom connector, which has got the authentication is based on an API key, since we have got the Azure function authorization level as function. I'll be showing that. And there is one single action on the custom connector. And one thing to keep in mind is the user should have premium license in order to use a custom connector in PowerApps. And this is something which you'll have to keep in mind. But there is you can actually publish custom connector from Azure API management. And if you've done that, and if you use the custom connector in Teams, and you can do it for free and with the standard Power App license. And at the last, I've got a simple Power App which consumes this custom connector, and it has got a couple of UI control. Whenever we turn on or turn off, it sends the message, it calls this Azure function. Right. So with that said, I will now show a quick demo. So I hope you can see my screen here. Right, so this is, I've got two lights, light number 1 and light number 2, which is a simple LED. Right, it has got a resistor here, and whatever you see here. So this one, it is the Raspberry Pi, and it is extended the GPIO pins here. So the pins are actually here, and it is extended using an extension cable, where I have used the breadboard. I've got the LEDs connected to pin number 17 and pin number 18.
Hello?
And yes.
Yeah, sorry to interrupt you. Okay. Is it possible to maximize your window, that window?
Yes.
Yeah, thank you.
Yeah. So I've got the LEDs are connected to pin number 17 and pin number 18. Right, so we have got two lights here, and which is also has got a resistor, so that it doesn't damage the Raspberry Pi. Right, so I will now directly show the Power App, and after that I will show the different how the different other components which I've used to enable this. So let me. Yeah, so before that, I will have to start console application program, right? And I will also show you a couple of configurations which I forgot to show you guys. So I'm now connecting. I'm going to use an MS Terminal Services, MSDSC, right, to connect to the Raspberry Pi. So the Raspberry Pi IP address is this one. I'm now connecting it. I've got a software installed on the Raspberry Pi which is called as XRDP, and this is software which enables you to connect, which will enable you to connect remotely. Yes, I'm using the default username and password. Yeah, so this is the Raspbian OS. Now I'm remotely connected to the Raspberry Pi. So the configuration which I've said, the secure SSH, so you'll have to enable that if you have to do the remote development, which I have done. So you have to go to Raspberry Pi configuration, right, and interfaces SSH, and this has to be enabled. And if you have to remotely code with Visual Studio Code with the help of the plugin. Right, so now I will quickly run that console application. So here, yeah. So this is the console application. So I will give a code walkthrough later. You can see here, I'm now connected at the bottom. I'm now connected to the Raspberry Pi using SSH. Right, in my blog post, I've thoroughly explained on how you can enable this. So let's now run this console application, which has got a code. As said, I will be I'll give a code walkthrough later. I'll just run it. And before running it, and you'll have to enable the, you'll have to give root permission to the GPIO pin number 17 and 18, which I'm doing right now. So pin number 17 is enabled and the mode is set to out. And 18 is also now enabled and it is set for out. And now we are ready to run it. .NET Run. Yeah, so now it is actually waiting for messages from the IoT Hub. Right, I will now quickly show the Power App. So this is the Power App which I have got. I will now enable, show the camera. Right, so here I'm turning on. Yeah, you can see here the light number 2 is lit and other one, light number 1. So both of the lights are lit now. The LEDs, I will turn it off. You can see here it is turned off, and also the other light. So this is how you can actually control. And now I will start explaining the different components which is associated to it. And now I will quickly show the IoT Hub in Azure. So and if you want to create an IoT Hub, if you don't have an Azure subscription and there are trials available, right? So you can extend it to 1 year. And also there is a free pricing tier IoT Hub which you can use it. I have already created the IoT Hub. I'll quickly show you the devices which I have registered. IoT this one. So this is the hub which I have registered, right? And next one is the devices. And once you register the hub, and it hardly takes a couple of clicks to create an hub. Once you have a hub created, and you'll have to register a device on your hub, right? I have registered 2 devices here. One is for the Raspberry Pi, and next one is the Arduino. Right. So here I have this device registered, and to create the device, you'll have to just enter the device name, and that is it. It automatically creates all the keys, connection string, etc. Right, so I have used here the message to device, and there are other ways as well to send a message to talk with your Raspberry Pi to to talk with IE, the input output pins, GPIO pins. And there is you can use direct method, and you can also use a device twin, right? I have used message to device, right? On a free tier, you'd be able to send up to 8,000 messages per day, right? So here I'll quickly show you. I'm just sending a body. It is like on one, and if I send it, the light number 1 will be turned on, which you can see here. So the light number 2, and if I send a message on 2, the second light will be enabled. You can see here, and it's off 1 actually turns off. Yeah, the light is turned off, and off number 2. Right, so I will now show the console application, give the code walkthrough of the console application. So here, yeah. So it is a very simple console application that has got the two package, Nugget package, which has already been imported. The first one is device.gpio, which I've already said to talk with GPIO pins on your Raspberry Pi, you need this package. And next one is for the Azure.devices.client, this particular package, you'll have to import it, and this facilitates you to receive message from the IoT Hub. And next one, there are a couple of variables you'll have to declare. And after you have registered an IoT Hub, created an IoT Hub, it will generate an IoT Hub URL. Right, so that you require it. And next one is the device ID. After you register a device on the IoT Hub, you get this, and also the device key. Okay, so here I have used, as I already said, the GPIO pin number 17 and 18. So I'm just declaring it here. And next one, so we are creating an instance of cancellation token source. So this is actually required. I'm using a task here. Hello, I believe someone is not on mute.
Yeah, I have muted. You can continue.
Okay, yeah. So here we have registered it, and I have also uploaded this code to my GitHub repository. You can take a look at it. It has got all the code walkthrough. You can understand it, why we require what functions. And next one, so here I am initiating and creating a device client, which is based on the device ID and also the device key, the connection string, which I've shown on the IoT Hub Azure. And now here I'm opening the pin. I'm creating a new instance of this particular function, a GPIO controller. This class, I'm creating an instance, and then I'm opening the pin, which where I'm also setting the output for pin number 1, pin number which is 17 and 18. The output is set here. Output mode, and it is not input. And if you are using a sensor, the pin mode should be input to receive signals. Right, so here the while, there is actually a while loop. So this is where once you start running the console application, the while loop, like it keeps running forever. Whenever there is a message sent from the IoT Hub, it actually captures here, right? So there are a couple of methods and classes which will help you to do it, right? So here, and once a message is received, right, it reads that message. What is actually the message? Is it on 1 or off 1, which I've already shown? And based on that, it actually turns on or turns off. So look here, if the message is on 1, right, and it actually sets the value of the pin number 17 to high, which means when a pin is set to high, it produces around 3.3 volt, which is more than enough to power up an LED, right? And if you have to power an real device, right? I'll quickly show the relay. So this is actually the relay. It is a 4-channel relay, and it is created for it supports a Raspberry Pi, and to activate a relay, you actually require a 5 volt. And if you have to know, understand how to use a relay on a Raspberry Pi project, and there are a lot of YouTube videos which you can take a look. Right, so here when you receive the message of number 1, so what we are doing here is the controller, the pin value is set to low, right? And if it is on, we are setting it to high, and if it is off, and it's set to low. So what actually happens is, and when it's set to low, the voltage which is produced on the particular GPIO pin is null, is 0. You will not get any voltage there. And then likewise, to turn on the second light on number 2, and it'll be turning on the pin number 18, and the same for the off number 2, and that is it. This is the console application. If you've got any questions, I will take it up at the end. And I will now show the custom connector. So we now have the console application, which is like running on the Raspberry Pi. So I'll have to show now the Azure function. So I'll quickly give a small walkthrough. So this is the Azure function. It is HTTP. It is an HTTP trigger. So I have used Visual Studio 2019 to create an Azure function. It is again a free service. I've used a consumption based plan, right? So it is free. No need to bother about the cost again. If you have got an Azure subscription, you can quickly set a publisher function and running on a consumption based plan. Right. So what actually it does is I've got the Raspberry Pi device, which is again registered on the hub. So the device and also the connection string. So what I'm doing here is when I make a get request or a post request to the HTTP function endpoint, it actually sends a message right to the IoT hub. So we are programmatically now sending a message through an Azure function instead of using the interface which you get it on the Azure IoT. Right, it is a simple function, and again I have posted this code on my GitHub repo. And now we have the function ready. Yeah, I'll also show the function. So here, this is that particular function, which is running on an app service plan. It is again a free tier, consumption based one. And here we have this function. It has got only one function endpoint. So the URL, right? So you can actually get the function URL. I'll now quickly show you. So we now have the function, right? So I'm going to make a get request. So I'm passing the parameter name equals on 1. You can now look at the breadboard. The light number 2 is turned on. Right, so we are now programmatically sending a message through the IoT hub. Yeah, and if I do an off number 1, it will turn off. Right, so this is the function. I will now show the custom connector. Right, so I have already said the users who is going to use the custom connector should have a premium license. But if it is used on the Dataverse for Teams, Power Apps, and it is for free. All right, so I'll quickly show the custom connector. What the custom connector does here is it calls the Azure function, which sends a message to the IoT Hub and which will be captured by the console application running on the Raspberry Pi. So here I will the security, right? So here the authentication type, and there are anonymous authentication type. If you have got to call an anonymous API, you can do it. But the Azure function which I have got is the authorization level is set to function, right? So you'll have to enter the API key, right? So the parameter, which parameter the API key will be, right? So here, if you copy the Azure function URL, it is actually the code, right? So that is why we have got the parameter name as code and parameter location, where you will have the name equals on one, where that will be. So that is on the parameter location, right? So now I'll show the definition. As I said, there is only one action, right? So which is used to control turn on or turn off, right? So what we are doing here is we are making a get request to the function. So this is the function endpoint, and the name is we are passing it on the query so that the custom connector can capture that. Yeah. So to create an action, it is very simple. If you'll have to just make what the request is, since because here I'll be so I'm making an HTTP get. So it has to be get, and you'll have to give in the URL. If it has got a header, you'll have to give here. And once this is done, right, and you can test it. And to test it, you'll have to create a connection. To create a connection, what all you'll have to do is, since the authentication type is set to API key, you'll have to give this API key to create a connection. And once a connection is created, you'll be able to test it, right? So here I will quickly make a test, right? So you can see here I'm making an on one, right? The light number 2 is it is on, and off number 1 it'll turn off. Yeah. So I have now shown the custom connector. So I will quickly now show the Power Apps. Yeah. So here I have added the connection to call the uh, custom API, the custom Azure function API. I've already added it, and I'll quickly show the code on select. I'll make it bigger. One sec. Yeah. So what we are doing is if the toggle value is on, and the value will be true, and we are once we have created the connection to the custom connector, once that is added, what we are doing here is we are sending on number 1, right? And if it's turn off, then the value will be the toggle value will be false, and the message whatever you have to do is send is off number 1, right? So that's it on the Raspberry Pi Power App. So I will now switch back to the presentation. I will quickly show the UNO one. Yeah, so the design is almost similar to the Raspberry Pi, but the only thing is we don't have a Raspberry Pi which is running an operating system. It is just an hardware board, Arduino UNO. It is hooked up to my Windows laptop through a cable. I will show you at the end how it is hooked up. It is through an USB port and with the help of a cable. And what we have got is, and if you have already used Arduino, the software which I have mentioned. And there you'll have to create something called a sketch or Arduino sketch. So this one, the sketch, it will enable you to talk with the Arduino board, and you can set the value of the input output pin as high or low, and it is something similar to what we have done on the Raspberry Pi. I'll quickly show you, you'll be understanding. Another thing is exactly similar to whatever I've got there, right? So here, and apart from the sketch, and there is also a .NET Core console application running on my laptop, right? So which the console application, it kind of talks with the Arduino through a sketch. I will show that. So here, what we are using here is in Visual Studio, the prerequisite, what you actually need is you have to install an Arduino software, which is available for Windows, Mac, right? I'm not sure if it is for Linux, but I run in Windows on my laptop. I have used the Windows version, so I have installed the Arduino software, and on my Visual Studio code, there is a plugin which is called as Arduino. You can just type in Arduino, install that plugin as well. And with that, I also have a sketch. I will show that. The communication actually happens through the serial port, serial USB port, and it uses COM ports here. And we should also upload the sketch. I will show that. You will understand when I actually show the sketch. And everything else is similar. And except on this console application, you need the Nugget package called as system.io.ports. It's again created by Microsoft, and it is actually actively maintained. And IoT Hub, Azure function, it is all same as for the Raspberry Pi. Yeah, now the demo. So yeah. Yes, so this is the one. And before that, I will show that software. So this is the Arduino software. This is how it looks like, right? And there are various examples which you can use it, right? To if you have to kickstart your development or do some projects with your Arduino board. And there are a lot of other lot of Arduino boards which is available, and I have used an UNO board. Right, so here, yeah, so you'll have to select which board you have to which you are using, and also you'll have to select the port, right? The USB serial port. And once this is done, you can write your sketch here. I'll show the sketch which I have used it on the Visual Studio Code. So on the Visual Studio code, instead of using the Arduino software, it is possible to create a sketch and also upload the sketch right within the context of Visual Studio. You're not required to go to switch interface to the Arduino here. So this particular interface to create the sketch, right? So here it is a very simple sketch. So what we are setting up the pin, the GPIO pin to 13, and to receive the message from the console application, we are initializing a variable, a character, right? So here we are starting the serial communication with the USB port, right? And we are now setting the output mode of the pin number 13. So in my case, and initially we are turning off the LED pin to off. We are setting it to low, right? And when it is kind of init if you compare it with other programming languages. Here, so it is the loop. So what we are doing here is, and if we receive a signal from the console application, if the signal if that particular signal or the character, if it is A, we are setting it to high, right? This is how we are doing it. And if it is B, and we are turning it off. I will now quickly show the program console application. So it is on the same console application. I've got this a particular file .ino. So I'll be writing a blog post about this shortly. Maybe by next week that'll be ready. I'll be giving a complete walkthrough on how to create this file and everything about this UNO board. And it is exactly similar to the one which I've already shown you. The only difference is here, the device ID on program, the device ID is set to my Arduino device. It is not the one which we have for the Raspberry Pi. And next one, everything is same, right? So here, okay. So this one, when it actually runs, when you run this program, you'll have to kind of enable the connection to the serial ports. The communication, you'll have to enable it. And once that is done, right? So we are now open the port, the serial USB port, and once that is done, and it is similar. So if it is on number 1 case, and it sends a message to the Arduino sketch, which is A, and if it is off number 1, it sends a message to B, right? So let's now quickly upload the sketch, and the command to do is Control Alt and a U. So I'm now uploading the sketch within the context of the Visual Studio Code. The sketch is getting uploaded. It takes a while, and you can also see here the board I've selected it as Arduino UNO, and also the port. It is COM4. Yeah, the sketch is now uploaded, and now I will I will run the .NET program. So .NET run. Yeah, so it is now waiting for the messages. So I will quickly go to the.
We have 10 more minutes.
Yes. Where I'm trying to go to an IoT Explorer. So this is again a software which will enable you to send messages to the IoT. Yeah. So here, whatever devices we have registered on the Azure IoT Hub, you'll be able to see that. So the Raspberry Pi, and we have got one for Arduino device. Right. So here I'm going to send a message. And if I do an on one, right, so you can see here the red light is turned on, and if it is off one, the light will be turned off. So that's it, and this is how easy to connect to the devices and create some cool integration. I'll switch back to the presentation. I have given all the references here, which will be shared to you all. Right, so here, and how to remotely connect to the Raspberry Pi with the XRDP software. I've also given the blog post with the post which I've written, and also the GitHub repo, where whatever code I've shown, everything is there on my GitHub. And also, if you don't have an IoT, don't have a Raspberry Pi device with you, and there are simulators which is created by Microsoft, which you can leverage to kickstart your IoT projects, right? So that is it from me. Any questions?
Hello.
Yes.
Yeah, in IoT Central, there are some kind of simulator devices, right? So can we replace our original? I mean, can we just avoid wasting
I can't hear you.
testing?
I lost you in between.
Okay, am I audible right now?
Yes, you are. Yeah.
Okay. So can we use simulated devices in place of a real device for the testing purposes in IoT
Yes.
Central?
Why not? There are a lot of simulated devices in IoT Central. You can use it. Yes.
Okay, okay. Thank you.
So, any other questions? Feel free to unmute yourself and ask if you've got any questions. And also, you have got the link, my LinkedIn URL, and you can ping me if you've got questions anytime in the future.
Hi Mohammed, Praveen this side.
Yes.
Yeah, do we have any connector already available in PowerApps to directly connect to IoT device or simulator rather than creating of Azure function and creating web APIs?
Uh, no, as far as I know, there is no connector. No, no, not at least a standard connector. As of
Okay, yeah, thank you.
yeah, and I've already done this integration with Google Home, right? So when I talk to Google Home, it'll kind of connect or start the light or turn on or turn off the devices with through the Raspberry Pi. So I've used homeassistant.io, and if you're interested, you can explore there. And there are a lot of tutorials available in YouTube, which you can take a look. And moreover, you can, if you have got a Power App, you can also use it on Teams, right? So you can turn on or turn off devices from Teams, and also you can even call and activate this function, activate the devices using a bot, Azure bot. And once you have come to this level with all these functions, an API endpoint, and it'd be easy for you to use it on any other like bots or Google Home, etc. So any other questions? I will also be monitoring the chat. If there are any questions, I will after this session, I will try to answer.